What you have communicated to me is that there have been far more viable pathways to life springing out of no life than was previously something I thought was a thing. I thought, oh, something lightning, something hot air events, something whatever chemical processes. But you're indicating that there are a lot of different ways, and that life coming to exist is not that surprising, at least in our environment, in the Earth.
In fact, I think the most compelling hypothesis for abiogenesis is the clay hypothesis, which we'll get to. So it literally means the thing that later became life was originally
That's so
clay.
biblical. Oh my gosh.
Oh, shit.
What are you doing?
Oh,
Would you like to know more?
I remember listening to a podcast or something with Andrew Tate where he was talking about him getting blood work done to prove that he wasn't doping. And he couldn't remember really anything about his actual blood work results. And he kept saying hydroglobin, which is not a part
hydroglobin?
It's not a thing. Hydroglobin is not a thing.
Hydroglobin. Do you think he meant hemoglobin?
Yeah. I mean, at first he knew. I think at first he got it wrong by mistake, and then probably saw how everyone was looking at him, and then just kind of leaned into it because he's like, "No, I'm not one of you."
Yeah. But I said it's hydroglobin. It's now hydroglobin. Like the king, the reason why I'm wearing a vest right now, and the reason why, if people don't know this, you don't bottom the bottom button on a vest, is because the king, I want to say, I forget which, it might have been King Henry VIII, because he got so fat at one point he couldn't button the bottom button.
I thought it was the regent. Didn't you say it was the regent, the Prince Regent during the Regency era?
Oh, it might have been.
More when vests were a thing. So like,
so he couldn't wear the bottom button, and then that just became the style. You don't wear the bottom button. So Andrew Tate makes a mistake in how he says hemoglobin, and now that's the new style.
No, it's hydroglobin, guys.
Hydroglobin.
Yeah, it's official. At least if you're a baller.
Episode is one I have sort of been putting off for a while because it requires a lot of technicalities to talk about, but it's to me an incredibly important topic because I see it talked about in online spaces. We've entered a world in which education has gotten really, really bad. Okay. Especially along things that could have like challenge woke stuff, but also stuff that can be overly challenging sometimes to religious stuff.
Yeah.
So I'll ask you, in school, did you ever study abiogenesis? Did you ever study how the first life evolved on the planet?
Never. Definitely, certainly, absolutely not in high school. And then in college, in historical geology class, we did discuss like and we glazed over it. Like it could have been chemical, it could have been whatever. And like but we didn't go in. I never heard that word.
Yeah. Well, and it's worse than that. What really got me is actually talking to Robin Hansen. And he had said that he was
talking about great filtration events, right?
He's talking about great filters. So if you're talking about the Fermi Paradox, this actually becomes a very important thing to have information on and know about, because you need to judge in your calculations of like, why haven't we seen other aliens yet? Is it unlikely that life evolves on a planet with the preconditions for life?
Right.
And he said it was very unlikely. Like that was one of the biggest filters, was that the first life came on our planet. And I think if it's a topic that you're particularly educated on, and he said, when he said it, he's like, and weirdly, a lot of people who are studying this area don't think it's that big a filter. And he's like, and I don't understand why. Like, and this to me just had me realize it must just be that he's never dug that deep into it as a concept, because it is actually not a big filter. Life appearing on this planet. And this is another problem with a lot of attacks that religious people will use against atheism that just don't land very hard because they haven't studied these subjects in a lot of detail, or they just haven't put a lot of thought into these subjects. Life evolving on a planet like Earth was incredibly likely, almost guaranteed from what we understand right now.
Bold claim.
So first, you need to understand why it's almost guaranteed, because you need to understand what you need as a prerequisite for life and all its complexity that we know it as having now to first come about. What you need is any type of, it does not need to be RNA. It doesn't need to look like life today. In fact, I think the most compelling hypothesis for abiogenesis is the clay hypothesis, which we'll get to. So it literally means the thing that later became life was originally
That's so
clay.
biblical. Oh my gosh.
Oh, shit.
What are you doing?
Oh, we just went over the Adam and Eve story and we didn't talk about
Did
clay.
you just talk about
Well, I tell you,
clay?
that story has all sorts of truths in it. It did a very good job of capturing the truth of reality in
Oh
a very
my
big way. And that's
God.
why I think that it had some sort of actual spiritualist, or not spiritualist, but like some sort of supernatural inspiration to it. But let's go back to this and stop talking about the religious stuff, okay? Clay, I think, is the most likely answer. And maybe the Bible is pointing to us that actually is how life started. But this is something that people really get wrong. They think that the early life needs to kind of look like life today, and it really doesn't. All you need is a self-replicating pattern
Okay.
that has some degree of variability in its replication. That is it. You need nothing else. Any simple self-replicating pattern will eventually, given enough time, become something similar to life as we understand it, so long as it has minor variabilities in that self-replication.
Because the minor variabilities allow for evolution.
So if you have something really, so this then comes to something that a lot of people like don't get, right? Like, so they talk about Spiegelman's monster. So I should talk about Spiegelman's monster really quickly. And they think that it makes it look unlikely that abiogenesis happened, when it's just a misunderstanding of abiogenesis. So
what is Spiegelman's monster?
Spiegelman's monster is an RNA chain of only 218 nucleotides that is able to reproduce by the RNA replication enzyme, RNA-dependent RNA polymerase, also called RNA replicase. So basically, Spiegelman introduced RNA from a simple bacteriophage into a solution which contained the bacteriophage replicase, some free nucleotides, and some salts. In this environment, the RNA started to replicate. After a while,
Oh shit, he created life. You're not supposed to
Spiegelman
do
took
that.
some, not exactly. He took
People
part of
freak out.
something that was already living and then put it in a solution.
Oh, okay. He remixed. Okay.
So shorter RNA chains were able to be replicated faster. So the RNA became shorter and shorter as selection favored speed. After 74 generations, the original strand with 4,500 nucleotide bases ended up as a dwarf genome with only 218 bases. This short RNA sequence replicated very quickly in these unnatural circumstances. So when people are arguing against abiogenesis, they go, he took something alive, put it in another solution, and it got simpler basically over time. That is the antithesis of evolution in their mind. But that's not. That is the thing that was more fit, the thing that was able to replicate faster within that environment, out competing the things that replicated more slowly. And eventually, after a certain period of time, the things that are replicating very faster, one iteration of them will develop some mutation that like prevents the ones around them from replicating as fast, or maybe starts consuming some of the ones that were replicating around it for the energy that are in them, or there's all sorts of little things that it might evolve, little chemical tricks it might evolve that give it a leg up that allows it to outcompete the other ones.
Sure.
And then you begin to get evolution going in the other direction. But even when you are talking about like evolution on Earth today, typically when you first put something in an environment that is just like abundant in food and has no natural predators, you are going to have that thing become quote unquote simpler because it's losing its defenses. It's losing all of the complicated things about it at first. This is something we see in evolution, you know, the classic dodo bird, although that's not really a good example, but it's the way that people think about it in their mind. Like it lost flight, it lost a lot of its defensive mechanisms because it didn't have those types of predators in its environment, and it didn't need those defensive mechanisms anymore.
And it was more efficient to just be a simpler bird.
But in Spiegelman's monster, you're having this on crack basically happen, right? You know, you're having the true simplest self-replicating pattern end up winning. And I should also note that there has been further work. So if you look at the work of M. Sumper and R. Luce of Manfred Eich's laboratory, replicated the experiment, except without adding RNA, only RNA bases and replicase. And they found that under the right conditions, the replicase could spontaneously generate RNA, which evolves into a similar form as Spiegelman monster.
Wow.
So what you're seeing here is sort of a convergent evolution of this simple replicator within this environment, right? But I actually don't think that this is particularly important to me. So first, something to note before we go further. There are many hypotheses for how life first evolved. And basically, whatever somebody studies, they'll think that that was the first thing that evolved. Because as soon as you understand something well, a part of life, you realize how it could form under natural circumstances and then start to have evolutionary pressure begin to apply to it.
Yeah.
So people who study lipid bilayers think that like the cell membrane was basically the first thing that evolved. And you had these the people who study mitochondria think that the very first thing that happened, I think this is the second most likely answer, is that the C cycle, a simple C cycle, a chemical cycle that creates energy, was the very first thing that was self-replicating, because we see these self-replicating nature all the time. So it's already like a self-replicating thing. All you need is some variation within it and a stable enough environment for it to replicate for a while that it begins to build up protective mechanisms and stuff like that. People who study RNA and DNA, well, they believe in the RNA world. They think that RNA was the very first thing that existed.
Availability heuristic. There you go.
Well, it's not really, it's more than the availability heuristic, because it shows a truth to me. It shows that everyone who's a specialist in a specific thing that could have been the very first thing that led to life believes it is so likely that their thing was the first thing that evolved to life.
And so you're just trying to show that this demonstrates the abundance of plausible ways that you could create life, that there's so many different, very realistic pathways.
Yes. Yeah. And so this is really important to understanding all of this. But I could take a moment to go over some of these pathways, because I think that they are, so you got chemical evolution, you got the RNA.
And then we'll rate them in the end from who's the hottest to who's the ugliest.
Well, I don't actually, I'm not going to go through them all, because I know you hate episodes where it seems like I am just talking. So I'll talk about some of the more specific ones, right? Yes. So the two that I find the hottest, the ones that I'm most convinced by, is the citric acid cycle hypothesis, which says the citric acid cycle is a key metabolic pathway. It can self-replicate. Could it have been the first thing? Yeah, it could have been the first thing. The other one that I think is very likely is the clay hypothesis. Mineral substances
let's go into the clay.
Could concentrate organic molecules and enable polymerization. So basically, it's concentrating organic molecules in really simplistic patterns, and the molecules are replicating within these sort of two-dimensional surfaces or crevices within the clay, which creates.
So clay is defined as like wet dirt.
Yes. And the reason why the clay hypothesis is so compelling to me is because it creates such a stable environment. And the stability of this early environment is what makes it so plausible to me, because you have other things like the beach hypothesis, basically. This is to say that the environment that created the first life was the waves lapping on the beach. So if you just have
the repeated mechanical...
Yeah, you have a repeated mechanical thing, and then the thing that it's lapping against could find a way to use that energy to essentially self-replicate some simple chemical pattern. Or some simple lattice or something like that.
Well, I mean, you're putting matter into so many different patterns and configurations that eventually you're going to get something that's...
Yeah, the problem is that I think that those patterns are too subject to, because you need energy, but you need not so much energy that it disrupts the patterns. Right? So if you have heat, for example, the heat helps with this because it's useful in a lot of sort of protein interactions and different ways that energy is created. But if you have too much heat, it denatures everything, right? And it's very hard to keep stable chemical reactions. Actually, I want to talk about a side note here, what a lot of people have probably heard about, and I want to... So the Urey-Miller experiment is one of the most famous experiments in this place, where he basically puts a bunch of chemicals together, and he saw that you got simple biological chemicals begin to form in this soup. And a lot of people are like, well, this shows... I really just don't think it matters at all what he did in that experiment, to be honest. First, it's had some issues with replicability, which a lot of people don't know about. But second, it, to me, shows why the chemicals that we are in our body, because it shows that those chemicals might have existed in the natural environment with abundance when these very simplistic early things were evolving. And so when they were grabbing stuff, they were grabbing what today we think of as biological chemicals. They weren't biological chemicals at the time. They were just the chemicals that were present in this like early Earth's soup. So no, I don't think that the Urey-Miller experiment really makes abiogenesis any more likely.
Can we jump back to the citric acid hypothesis?
Yes.
So I'm only familiar with citric acid as like an ingredient in foods. Was citric acid incredibly abundant in early Earth? Like, how does this all...
The citric acid cycle is a cycle by which certain metabolic processes are done. Think of it like a simple chemical reaction. And I one, I don't remember the reaction exactly. I can put the molecules on screen, but it is very simple. It's simple enough that you can see it on screen. You can be like, oh, that's the citric acid cycle. That's the only thing that needed to happen naturally to then lead to complex life.
Interesting.
So, but it needed to happen within an environment with stability, changing environmental pressures, and a level of energy within that environment, because the citric acid cycle is working on energy within these environments. So that's
Okay.
important to note. But then there's different sources here. So to go over other common hypotheses that are sort of worth talking about, God, what was it? The radioactive beach hypothesis. Radiation from mineral beach sands powered chemical reactions, and then the waves created sort of a changing thing.
Oh, very superhero. Loving that.
You have the PIH world hypothesis. Polynucleic aromatic hydrocarbons provided a template for the origin of RNA. The phosphate forced hypothesis. Phosphates could have helped organize protocells and been an energy source. And then you have some of the hypotheses that people are probably more familiar with, like the deep sea vent hypothesis, suggests life may have originated around hydrothermal vents in the ocean, where heat and minerals could drive chemical reactions using hydrogen, sulfur compounds, etc., as energy sources. The porous vent structures could serve as natural chemical reactors, which is true. Sort of what is said within that is, remember how I talked about the problem with like disrupting environments and you need enough energy in the environment? Well, what this hypothesis states, which could actually be true, is these deep sea hydrothermal vents sort of protected. They created energy, the heat that's coming out of these hydrothermal vents, but they also created a semi-protected environment from things like earthquake, lightning strikes, radiation, everything like that, where you could have a stable environment for long enough for a self-replicating pattern to become complex enough to leave this sheltered environment. And this is
interesting.
In the environment that everyone's familiar with, but we should also talk about, is the panspermia hypothesis. The panspermia hypothesis is that life on Earth was actually seeded by life somewhere else in the galaxy.
That seems to me just like shunting the problem down the road, because they're like, I don't know, it came from somewhere else.
Well, I mean, it's not a ridiculous or sci-fi explanation.
Well, you still have to answer the question of how it came from somewhere else, where it came from somewhere else.
Not really.
How did life come to be then?
So saying that life evolved somewhere else does kind of solve the problem, because you could say that it evolved in a completely different environment where it was much more likely to come to evolve.
Well, we kind of get the gist of planetary mixes. They can be hotter, they can be colder, they can have different chemical compositions. What would make life easier? I mean, what I always hear people muse about is that it's just so insanely lucky that Earth had all of these very convenient things for carbon-based life.
That's a teleological argument. I mean, life is only going to evolve on a planet where it's likely to evolve.
Right, except that you're saying that life, we're talking about the theory that life came from some other planet. And then you're still going to have to explain to me how life emerged on that other planet.
Yeah, I also don't believe in panspermia for another reason, which is a perhaps more interesting reason. It's not that I do not assume that some species out there have panspermic patterns. And I think that we might become one of those species where we seed planets with biomes before we travel to them so that they can grow into full ecosystems.
Couple goals.
Yeah, well, I've looked at doing that myself. I even looked at seeding other planets with life. How much would it cost? Because you can buy a spot on a spaceship for like $50,000, which gets you out of Earth's orbit. I mean, for like a capsule, not a spaceship, but it's like a rocket. So then we would ship from there to various planets with things that I had used serial evolution to make resistant to those planets' environments, like the radiation, the heat, everything like that, to create a starter ecosystem that could then become a full ecosystem when humans got there, which would make the planet potentially more habitable to humans, especially if you pre-engineered this ecosystem to emerge in such a way that created something like an atmosphere, which would be very useful to us in having the things that had already collated the energy on the planet and energy from the sun into something that we could burn or eat, which we would likely be able to as most of these if they came from our planet originally, and then they wouldn't have any defenses to us. So it'd be great. It's a good system. It'd just be a horrible act of international terrorism in the eyes of NASA that does everything they can to prevent contamination of these other planets with stuff on our Earth, because then we can't tell if life evolved independently on these planets, which is something they're very interested in. So for obvious reasons, it would be meaningful if it turns out that life evolved on the moon as well. Now, or if the Earth seeded the moon, or if whatever seeded the Earth seeded the moon. But I don't believe the Earth was seeded. And I'll tell you why I don't believe the Earth was seeded. most species that used panspermia as a evolutionary strategy, i.e., they seeded something like themselves on a planet and then they waited for that thing to develop to a certain stage, and then that thing would seed planets with like a more primitive iteration of themselves that would then become like a more evolutionarily grown up version of themselves and seed other planets. It would have seeded it with some sort of code that more guided evolution than early life on our planet appeared to have. It would care that the thing it had seeded the planet with in some way was like itself and would quickly become the type of thing that could colonize other planets.
Yeah.
If I was a super intelligent entity, or even slightly more intelligent than I am now, with more knowledge of gene engineering and stuff like that, I could code some sort of bacterial life with like junk DNA segments that would allow it to evolve much faster than a normal bacteria can evolve. And we don't appear to have these. We don't appear to have this important code. We don't see like super useful code to human DNA in like lower animal species and stuff like that. Maybe they did. Maybe we were like a failed panspermic planet where they included this code that would guide the evolution down a specific pathway, but the code didn't take effect in the way it was supposed to take effect, and it basically has all been washed out of whatever came on Earth. Or they seeded Earth and Earth was competing against a native organism and the native organism won, or maybe consumed it or something. There's this is how we think mitochondria formed. It's that mitochondria used to be an independent type of organism, and it and other early organelles was one cell eating another cell that was just a completely different entity. And so every cell is one type of organism that ate another type of organism, and since then have been evolving together because it turned out that they were useful to each other. That's how evolution works. So yeah. Now, do you have questions, Simone, or areas of this you want to dive deeper into? Or do you feel you have a better understanding now?
What you have communicated to me is that there have been far more viable pathways to life springing out of no life than was previously something I thought was a thing. I thought, oh, something lightning, something hot air vents, something whatever chemical processes. But you're indicating that there are a lot of different ways, and that life coming to exist is not that surprising, at least in our environment, in the Earth. Why
No,
then, given all
continue.
this, is there not life on planets adjacent to us that also have at least some of these conditions at play?
Well, you can watch our Fermi Paradox video on this particular question, because that was one of our early videos. It was on the Fermi Paradox.
And I do admittedly remember nothing of anything ever.
But it's an important question. It's why the Fermi Paradox is an important question. Any world perspective, I say, that does not take the Fermi Paradox seriously as a question is not a world perspective I have any respect for. You need to be able to answer why we are not seeing aliens everywhere, because we really should be. We really should be, if our current understanding is correct. The filters might explain it, but the filter is likely not the beginning of life. I think that the most likely filters are actually three other filters. One is single cellular to multicellular or a complex life. It appears to me that the embryogenesis of simple life is actually very likely. It happened almost as soon as it could happen on Earth, like almost as soon as the conditions were right in terms of like the scale of the universe. But moving from single cell to multicellular organisms actually took some time. And it might be that jump is actually pretty rare, because a lot of the time you're almost always going to be better if you're simpler, unless you're dealing with like very specific circumstances, and then you begin to get the proliferation of these complex entities, especially during times of change. I mean, when there have been cataclysms and stuff like that, it's usually the simpler generalists which survive them, and the more complicated specialized entities that don't. So that's one big filter. The other one is the evolution of intelligence. I actually do not think that this is as big a filter as people think it is. I think intelligence was almost inevitably going to evolve given enough time once you have complex life. It's almost as inevitable as sexual reproduction. So like sexual reproduction, what sexual reproduction allowed animals to do is, instead of just cloning their genes exactly, it allowed them to mix them up against, which allowed for faster intergenerational but still stable mutation. And the selection of good genes at a higher rate, because you could have one entity have a mate with a bunch of different entities if it had uniquely good genes. Now with intelligence, So you look at something like a spider. Spiders can do amazing things with webs and stuff like that. Like they have a form of like mental capacity to do these things. But that web to improve, the spiders that made webs bad need to die. In humans, to improve our houses, we are sort of able to create mental models of the world and have those mental models compete against each other in a completely mental space, and then implement the mental model that we think is most accurate in reality. That is what intelligence is ultimately. And that is incredibly, like, it basically hypercharges the evolution of our software for how we do everything, how we hunt, how we build, how we communicate with each other. And one of the things that people often note on humans, and I think this is an important thing to understand, is humans are not a species that is evolved for civilization. We are not a species that is evolved for like technology. We are just the dumbest, least evolved thing that was capable of building those things. And I believe that we have a duty from God. We believe it's a divine duty to make ourselves a type of thing that's worthy of these gifts, which means improving ourselves and uplifting ourselves. Because right now, I mean, we are basically monkeys that figured out that have like the barest understanding of technology.
It's not going well so far. We're not.
But it's not going well so far. And I think that with AI, we're beginning to see just how limited our capacity of understanding is. That it took our species, from creating the first cities 10,000 years to creating something that's smarter than us, which is fascinating to me. Well, smarter than us in some ways, not in all ways, but I think anyone who's like AI won't be definitely smarter than us within 100 years is in 100 years, when you're talking about this 10,000 year time span, I think that's just silly when looking at the current advancements that we're seeing. And I don't see that as a threat. I see it. We'll talk about this in the future. I think that, we'll use it to augment ourselves, and that we have done this with technology all the time. The first time somebody put glasses on, are you man or machine?
Overwhelming, am I not? I'm more than machine or man. More than a fusion of the two.
But I think that that's where we are realistically going as a species. And we'll talk about this in upcoming track. But I think that when you say entities that are different from us in this way, and this way is a way that entity can be better than you, are not allowed to exist, then you create a mandate for entities of that type to kill you.
No, it's not a good move.
It's not a smart move, whether that is genetically augmented humans or AI or anything like that. We've got to learn to get along. And for that reason, racism is an existential threat to our species, not just a minor threat, because if things that have this sort of racist mindset are among the category of things that get uplifted, they will start to kill those of us they see as lesser than them. So we cannot really tolerate these kinds of attitudes or mimetic structures within humanity anymore, because the game is yet again changing after the evolution of intelligence. I don't think the evolution of intelligence was unlikely. I think actually the second great filter after single cellular life is an intelligent species not killing itself. I think that intelligent species probably in the grand scheme of the universe usually kill themselves. I think we made it off the skin of our teeth, what's the word here? Skin of our fingers, skin of our teeth,
skin of our teeth, which is indeed a weird idiom.
Through the discovery of nuclear power. And we are about to enter a period of trials, the trial of the Lotus Eaters, the trial of the shadow, where humanity may not survive these trials either. And they are trials that every sentient species is going to eventually come to. The trials of the Lotus Eaters, we invent a world in which you no longer need to labor to live, and in which you can get any pleasure you want whenever you want it. Can you still motivate intergenerational progress of your culture and society? And I think if we didn't call those individuals who couldn't motivate reproduction in the face of these things, we would become a species that also no longer innovated. Yeah. And that tried to just live forever and maintain their lifestyles, which is, one of the highest orders of all sins within our religious structure. So, yeah. Any final thoughts, Simone?
No, but this was interesting. I'm always surprised by how much you know, Malcolm. And I especially am always surprised that I can still learn new things from you, even though we've been married for this freaking long. Together for this freaking long. So thank you for that.
I don't know that much. I just know the things I think are important to know. And this is one of those categories of things that is pretty important to most world perspectives. Was it like like
Yeah,
the
but most people, myself included, learned the basics of these and are like, am I going to need this? Nope. But you have a very different perspective of what's
it
a
matters
need
at
to
the
know kind of thing.
existential level. You do need to know it.
Yeah, but
Because-
most humans are not very interested in existential issues. At least if I'm...
But if you don't know the existential issues and you don't know what to optimize with your life, and you end up like an idiotic general
But
utilitarian.
Malcolm, we have templates. You don't have to worry about that. Just do what everyone else is doing. We've been doing that for ages. Besides, it's safer because you don't want the tribe to kick you out. So I'm just saying.
The tribes
not
always
normal.
kick us Collinses out. You know that.
No, you just have this weird, next level demigod style way of thinking that is totally not human, and I'm onto you.
Well, I appreciate that you say that. Oh no. Well, here's what I would say. I think it's always funny when people of different religions get excited that we take a deep interest in their religious system,
No.
and then after we do it for a bit, they start to become very upset because we are very harsh and critical. Once we understand it, we're like, oh, okay. Well, I don't believe this. This doesn't seem plausible. This doesn't seem plausible. And we're like, no. I meant like just accept it. And I'm like, well, no, I'm taking this religion seriously. If this was written by God, then you're not doing it right. And this part doesn't even look like it was written by God. So this has become a recent big passion of mine is going through the various Abrahamic faiths and trying to understand what were revelations from God and what was sort of cultural pollutants from their neighbors. It's a difficult thing to do because, a lot of people from these traditions, they don't want to say that anything with antiquity could have been a cultural pollutant. Everything of antiquity must have come from God. And it's like, well, I just don't think that that's obviously true. I think that it is easy for cultural pollutants to enter. And I think that's why God has given us a sequence of prophets. And he has made this prophets evidence by the gifts of philosophy and science he has given to the people that accepted those prophets after they accepted them, and then removed from those groups after they again turned to iconoclasm and mysticism.
Yeah.
So, we if we are to receive God's blessings, need to approach science honestly and not sort of try to, what's the word I'm looking for? Kneecap the things that might challenge our faith, because truth can never challenge truth.
Yeah.
Anyway,
True.
I love you to death, Simone, and thanks for today.
I love you too, Malcolm. Oh God, you're so amazing.